All right. Hello, everyone. Welcome. Let's see here. I think we're going to start today with Liz. Do you have anything to say before we launch into Trey's presentation? Liz, I cannot hear you.
No, just welcome. And yeah, we'll go ahead and start with that. And do you want me to introduce him or do you want to?
Yeah, that would be great if you would.
Sure. So we're excited today to be hearing from Professor Trey Cade from Baylor University. And he has been teaching there for many years and has a great background has done a lot of research into some of the history of space weather. And we look forward to hearing about that, as well as anything else you might want to share with us about your research or education there, Trey. Thank you.
You bet. All right, let me get set up here, share my screen and all that.
We'll admire your shirt that says Space Weather Research Lab. In the meantime, it's like, I recognize some of that.
All right, can you see my screen?
Mm-hmm.
All right, awesome. Yeah, so I am not a historian. I just pretend to be one. But when I teach my space weather class at Baylor, I kind of teach it from a historical perspective. So I kind of bring students through kind of the how our understanding of space weather progressed over time, and that's kind of how I teach space weather to them. Since it's normally a it's mostly non-science major students that I'm teaching, so I have to take a little bit of a different approach to teach the class. So so this is kind of extracted from some of the stuff that I use to teach the class. But just kind of dip into a little bit of how kind of how humanity's study of the aurora kind of started out, and we'll start with kind of the humans' earliest interaction with the aurora. Certainly, the aurora is the manifestation of space weather that humans had the earliest interaction with. And we can see here an example of early human cave painting. We believe that some of these cave paintings may be actual depictions of the aurora. The first possible mentions that we see of the aurora in written form, where people are actually writing about the aurora and what they saw, 2600 BCE in China. Possibly the first, like, where we're certain that they were actually writing about the aurora, about in the 600 to 700 BCE time frame in China and Assyria. Numerous mentions later on by Greek and Roman writers. We believe that there are passages of the Bible that may be describing the aurora as well, but certainly by Greek and Roman times, we start to see a lot more interest writing about study of the aurora, especially as we get to Aristotle. Aristotle wrote extensively about meteorological phenomena in general, and included the aurora as a part of that. Of course, he didn't call it the aurora. He called it chasmata. He thought that what was happening, and he was one of the first to actually try to provide somewhat of a scientific description of what he thought was going on with the aurora. And he thought that it was actually just gases in the atmosphere that were rising up to such a height to where they were catching fire and burning. Of course, that fit in with his kind of description of the universe as water, earth, air, and fire being the highest part of those domains in the celestial domain. So that was kind of his theory about what was going on. as we progress through time, the aurora was given lots of names depending on where you lived and what you thought about the nature of the aurora. So you see kind of a lot of different names here that were ascribed to the aurora in different parts of the world. And again, it kind of related to how you viewed the aurora. So where you lived and how you interpreted the aurora was very different depending on what part of the world you lived in. If you lived in more northern areas, Nordic countries, the indigenous peoples of northern North America, who saw the aurora frequently, and so it wasn't such a fearful thing for them. It was something that they lived with, and it was there a lot of the time. They tended to associate the aurora with their ancestors, with the spirits of their ancestors, the spirits of the dead. So there's almost this kind of familial connection to the aurora. Whereas when you look at other places that saw the aurora less frequently, it was very much interpreted as more of a fearful sign, as an omen of impending doom, or some type of dreaded event, a sign that something bad was going to happen very, very often. So your interpretation very different depending on how often you saw the aurora. Galileo, he wasn't the first. You'll see in some writings that some people say he came up with the term aurora borealis. From what I've seen and from what I've read, he didn't come up with the term aurora borealis. That had actually been used in other parts of the world, in kind of Nordic countries, for example. But he certainly was the one that seemed to kind of bring it into more popular use among large parts of the world, or at least larger community within Europe. And then the term kind of spread out from there. He speculated on the nature of the aurora as well, thought that it was just air that had risen to such a height to where it was the air was just reflecting sunlight from the sun, from the sunlit half of the earth, and so just reflected sunlight. Kind of a landmark event in kind of studying the aurora was the Great Aurora of March 1716 in Europe, where the aurora was seen over much of Europe. Before that, aurora hadn't been seen much in Europe, at least in kind of in Central Europe, for about 100 years, largely because of the Maunder minimum. So aurora hadn't been seen for decades, as I said, to around 100 years. And so there was this great auroral appearance in 1716. And it got a lot of people excited. You see a lot of writings, you see drawings of the aurora from this time period. It sparked the interest of Sir Edmond Halley, and of course he's most people know Edmond Halley with his connection to Halley's Comet, but he was also very much a researcher in geomagnetism and the aurora. In fact, he wrote a paper for the Philosophical Transactions, as you can see here, an account of the late surprising appearance of light seen in the air on the 6th of March. This is the 1716 aurora, with an attempt to explain the principal phenomenon thereof. So in his paper, not only does he attempt to compile various observations that were made of the aurora from various locations, but also attempts to try to come up with a scientific explanation of the aurora. And how he did that was he noticed three things about the aurora. The three things he noted first was that he noted the nature of a magnetic field of a spherical magnet. And this drawing of the magnetic field of a sphere is actually from his paper. And of course, you can recognize, most people will recognize that as the magnetic field of the Earth as well, what the Earth's magnetic field looks like. He also noted that aurora tended to appear more often the further north in the northern hemisphere. The further north you go, the more often you see it. Further south you go, it's less seen, and it's never seen, as you get closer to the equator. And then he noted, especially from the 1716 events and all the observations he was able to gather, as well as observations he made himself, that the auroral forms tended to be vertical, but as you move from north to south, those forms were less vertical. They tended to have more of a tilt to them towards the south. So he kind of combined those three things together to come up with a theory of the aurora that he came up with this idea that there was some type of a glowing, luminous magnetic gas that was inside the Earth. And side note, he thought the Earth was hollow and that people lived inside the Earth. But that this magnetic luminous gas seeped out of the Earth from in the polar regions. And so since it was magnetic, it was kind of guided by the Earth's magnetic field. And this glowing gas seeping out of the poles was responsible for the aurora. So kind of interesting here in that Halley, as far as I've been able to tell, was the first to actually connect the aurora to the Earth's magnetic field, to make that connection. And he also came up with his idea of this glowing magnetic gas, what he called an effluvia, a very similar, not exact, but a very similar concept to plasma, which that concept did not really gain shape in modern form until the early 1900s. So, but we see here the beginnings of a concept of something that is very similar to a plasma, a magnetic gas, essentially. So you could argue that Halley, being one of the first, true auroral researchers, where he gathered observations, as many observations as he could, as well as his own observations, used those observations, used his knowledge of the world, knowledge of the universe, of the Earth at that time, to really come up with kind of a comprehensive theory, integrating all of that together, a theory to try to explain auroral phenomenon, which is a pretty good attempt for the early 1700s. There were opposing views that were published about that same auroral appearance. This is an example of a pamphlet that was published, an essay that argues that the aurora could not possibly be a natural occurrence, that it had to be, basically what the paper argues is that it was a sign of God, a sign from God telling people that they needed to repent, that the end of the world was near, and that it couldn't be possibly a natural occurrence. So there were definitely other points of view circulating at this time regarding the nature of the aurora and what it was. You see this idea of viewing the aurora with fear commonly in the 1700s. You can see here, for example, this is written about about a 1719 appearance of the aurora in North America, and it talks about how they were extremely alarmed with the apprehension of the approach of the final judgment. So again, this idea that the appearance of the world was or the appearance of the aurora was a sign that the end of the world was coming. Again, not an uncommon view for how people saw the aurora in that time period. In 1733, we see the first textbook on the aurora published in France by Jean-Jacques Desmarest, who proposed that, and this was kind of a radical idea at the time, that he proposed in his book that the aurora was caused by the Earth interacting with the sun's extended atmosphere. And even the idea that the sun had an atmosphere that extended out into space was a pretty novel idea for this time period. So this is pretty remarkable that he was getting very close to kind of the beginnings of how people were to understand how the aurora occurs. Olaf Hjorter was an auroral researcher in Sweden. He was working with Anders Celsius of Celsius temperature scale fame. Celsius was also an auroral researcher. They were mostly researching geomagnetic disturbances, geomagnetic storms. And of course, the way that was done back in this time period was researchers had to basically stare at compass needles to watch for very small movements of compass needles to observe magnetic disturbances. But in 1741, Hjorter published a paper where he made a very unique observation for the first time that he wanted to bring to everybody's attention. And you can see here, he says, a motion of the magnetic needle has been found which deserves the attention and wonder of everyone. Who could have thought that the aurora and the magnet would have a connection, and that the aurora could, within a few minutes, cause considerable deviations of a few whole degrees of magnetic needle. So what Hjorter was connecting for the first time was noticing that when he saw the aurora, that also he observed a magnetic disturbance. And so for the first time, connecting those two phenomena, which up to this point have been separate areas of study, realizing that these things appeared to be connected somehow. Now, the mechanism for how the aurora and magnetic disturbances could be connected was completely unknown, but at least starting to realize that that connection existed. That allowed a few years later for an actual prediction to be made by Per Worgenton in Sweden, who later became the head of the Swedish Academy of Sciences. And this is from a paper that Worgenton published. He said, 4 o'clock in the afternoon, I saw that within a few minutes, the needle jumped westward 0.5 degree. So he observed a magnetic disturbance. He said, at once I predicted that we should expect aurora that evening. So based on observing a magnetic disturbance, he predicted that they would see aurora. And then he reported that this actually happened. So for as soon as it became dark, we saw one. We saw the aurora. So this is the first real space weather prediction that was made based on, again, the newly discovered connection between these two phenomena. So as we move into 1800s, some very interesting things start to happen. We see the Oersted experiment occur, which shows that electric currents can produce magnetic fields, and that led to great understandings about the nature of magnetic storms and the idea that the aurora is somehow connected to electricity. The science of spectroscopy comes about, and that leads to all kinds of revolutionary discoveries throughout various aspects of space weather science. And of course, the Carrington event occurs, a landmark event that connects a lot of new things together. But given the limitations of time we have today, that's that will be a story for another time. So I guess that's the end of the first chapter for today.
Awesome. Thank you so much.
Yeah.
So interesting. I really appreciate the really thoughtful, I can see how students would have lots of ideas from this, because I think we all might have lots of ideas and thoughts and comments and questions. I would like to propose that we might use this little thing I tried in a meeting recently that works really well. It's called the popcorn approach. So you get to ask your question, and then you can answer, Trey, and then you get to pass it to somebody else so they can ask a question. So it's kind of fun and kind of worked well for the virtual environment. So, and you know, if you don't have a question, you can offer a comment, or just, you know, mention what you thought about from this, or just pass if you don't feel like talking, but it's all good. Yeah, so I guess I will start, and this will also limit me to one question, or something. Well, I guess my question is, your presentation made me wonder, when people first started to do math on the Aurora to try and calculate the height.
Yeah.
I think there's some early, maybe 1700s, but maybe that was even way further back. I don't know. So, yeah.
That's a good question. If I recall correctly, I think some of the earliest attempts to do that using some simple geometry, basically combining two observations that are spatially separated and doing some simple geometry, trigonometry to try to get the height. I believe that's 1700s, and then you start to see that being used more into the 1800s. And people were getting various answers anywhere from, 50 kilometers, 100, 200 kilometers. So getting a wide range of answers, but they were getting answers that showed that, it was quite high. Some people, whereas, some people would report that they could see the aurora touching the ground. And you still see some of those reports persist late into auroral science, but when people were doing these actual calculations, they were showing, they were consistently getting very high values. So whatever was going on, it was occurring very, very high up in the atmosphere.
Yeah, definitely.
Yeah.
Thanks. So I would like to popcorn it to Jeremy, if I can. Maybe I should have said that before I asked my question, or before you answered.
It's good.
Awesome.
One of my takeaways, if you can hear me okay, somebody nod if you can hear okay. Yeah. Is that all the explanations of the cause of the aurora were fit to the understanding of the time, and the actual cause was sort of beyond the understood physics of the time, and when the physics evolved, they found new ways to fit it.
Yeah, definitely.
and it makes me wonder what things now we are fitting to what we understand, as opposed to increasing our understanding to encompass those new phenomena, especially with aurora. And in reading about electromagnetics and plasma flow, the one thing I realize is that as a human, you have an intuition for things like wind and water and even fire or something, but you have no intuition of plasma and magnetic field flow. And I always wondered what it would be like if sort of somebody had that intuition and they could explain or understand the motions of plasma and electrons, as well as somebody who's trying to explain what it's like to feel water on your hands or flow around a rock. So that those two aspects, I guess, about understanding, and the intuition one seems very interesting. It's like when they say if you're a dolphin, you understand sonar intuitively. So is there a sort of a scientific equivalent for understanding intuitively plasmas and magnetics? And maybe some people do have that intuition.
Well, and that's an very interesting comment. And I'll just tell you something quickly that kind of relates to that. That it's not very intuitive to understand things like plasma motions and things like that. Even the greats that we think of in space weather science. I mean, Sidney Chapman, one of the all-time great names in space weather science, when he first proposed that it was a stream of charged particles from the sun that interacted with the Earth that created magnetic storms. He basically proposed that it was a stream of electrified gas, but all of one sign, like all positive charges, like all ions. Someone had to point out to him that, well, if you had a stream of just, positive ions streaming from the sun, they're going to repel each other and they're going to spread out as they, as they go through space. And it's still not going to be this coherent cloud of gas when it gets to the Earth. So, even grades like that had to be pointed out, a flaw in understanding, because this stuff isn't, always really intuitive. So it took someone else intervening, pointing out his mistake, for him to rewrite his idea and say, okay, yeah, it has to be an overall electrically neutral gas. So it has to be a gas of both, positive and negative charges combined together. And that was really the beginning of coming up with the idea of plasma. But even Sidney Chapman needed help to figure that out.
Great for students. Who do you want to popcorn to, Jeremy?
Sorry, Rocky?
All right.
Sorry, what? I don't have any questions right now.
All right. Do you wanna pick someone else?
Oh, Hugo?
Hugo.
Hugo?
All right. Hugo.
Hi. To me, it was interesting to put names to people researching the aurora, right? Because to me, it's like I always think of like right now, but seeing these caves and Galileo and the Greek and Aristotle is like, to me it's like quite fascinating, because sometimes I'm a person that I don't really know much about like the science of the aurora, but I love history and in seeing that these scientists were like studying something new. I guess it's not new, but it's like, how do we explain this, right? So without like satellites and everything that we have now, I think it was pretty nice. So, and thank you, Trey, for the really nice video that you had for us. So that's
Thank you.
Yeah, I jotted down famous names as well, because it also struck me that just there's so many famous scientists and following in some of those footsteps and continuing today. It was really exciting. All right, Hugo, who would you like to popcorn to?
Let me see names, because I don't know. Okay, I'll go Christine.
Christine.
I'm going to second what Hugo said there, because I've seen presentations about historical auroral observations before, and today's presentation that Trey gave, he had a lot of different observations that I had never heard of before, and I thought that was really interesting. The one that I thought was most interesting was the one, I'm blanking on the name now, that they actually were proposing something like the solar wind long before anyone else had really, made this connection. I thought I'd never heard of that before, and I thought that was really neat.
Yeah, it's really pretty remarkable what some of these researchers were able to do with such limited observations and such really limited information about how things work. I mean, their understanding of physics was very crude compared to ours, very limited ability to observe things, and the ideas that they were able to come up with, although wrong in many cases, those, it's kind of like those, and this is kind of what I teach my students, is those wrong steps were necessary to move the science forward to enable eventually to get to the right answers.
Yeah, very cool. Christine, you get to choose a person here. I'm picturing the ball moving all across, North America. So from Iowa, where's it going?
How about Lynn? Do you have any questions?
Lynn in the Northwest. Awesome.
Hey, thanks, Trey. I really enjoyed that.
Thank you.
So what struck me was, as you were talking about how the Native Americans or the First Peoples or whatever, people that were up towards the poles saw it as something comforting, something that was good, because they saw it more often, right? And then as it migrated further from the poles, those people saw it as ominous because it was something rare to see. And that was interesting. Because I have researched some of the different stories that are out there, and I hadn't placed them geographically. So that was a really nice connection. I've researched, but not as decades as you have, more like weeks on my end. So I liked that connection. And then how things just happened by chance. I happened to look at my compass and it was moving during the aurora, and it's like connecting it that way. And some other discoveries that happened by chance, somebody finding a connection where they didn't think it was possible. And so I forget who was talking about, was it Justin that was talking about when he was talking about what don't we know now? And will it be something as simple as just somebody making a discovery by chance, because they're looking at something totally unrelated, and then all of a sudden it's like, oh, we can see plasma doing this now, type of thing. So that's really cool, and I enjoyed your talk, so thank you.
Thanks, appreciate it.
Awesome. Yeah, that was a great comment from Jeremy. Who do you want to popcorn it to, Lynn? And I wonder if you might, I can only see your screen, Trey, so you might stop screen sharing,
okay,
and then we can
sure.
see each other, possibly.
Yep.
So who?
It's a game of who's not been called on as well.
Yeah. Oh, Pat. Hey, Pat, how you doing? Would you like to chime in?
Okay, sure. No, in fact, I really appreciate that, the talk so far. I'm looking forward to part 2, because I think when we start moving to the late 1800s and early 1900s, then we can bring in Sturmer and Birkeland and people who actually used scientific methods, you know, admittedly, you know, early on methods, but you know, the methods of their day to get the height and to start to use spectroscopy, etc. So and to talk about the field line currents. It's interesting that you know, that very few people really understood the field line currents. I think that your point about Chapman, of course, is interesting, and he had a long-standing arguments with several people in the substorm community too.
Yes.
So,
Yep.
just because you're a big name doesn't mean you're always right.
Right.
Okay, so I will popcorn to you now. Carolyn, I hasn't said anything, so I'm going to stick you.
Thank you, Pat, and thank you, Trey. It's very enjoyable talk. And I didn't know Aristotle wrote about the auroras. That's very interesting. It reminded me, and I'm fact checking a project I did a few years ago. It's the space weather timeline. So I love your stories. Also about the indigenous viewing of the aurora, our partner at University of Alaska, Fairbanks, has a video on the indigenous view of the aurora, and people loved it. So I should find that link and share with this group.
Well, that'd be great. Yeah.
Yeah, another video is in the making and will be published by the NASA Space Place, is aimed at younger audiences. So it might be useful also to you, Trey, and to this group. Finally, Paul Brackey in Norway has shown us a dollar bill. I would love to own one that shows the aurora on the dollar bill. I forgot what's the face value, but one of the few paper notes that has, scientific values on it.
That's pretty cool.
Yeah. Thank you very much.
You bet. Thanks.
Okay. How about Rocky?
Oh, I think he was already.
I'm sorry, I didn't pay attention. Ooh, help me out. Who has not spoken up yet?
Laura.
Laura?
I'm sure Laura has some comments, and then there might be somebody else. And we'll see if anyone else has anything. Actually, Laura might be the last one.
Oh, good, because there are questions.
Yeah.
This is
I'm picturing
fantastic.
you sitting on your hands the whole time going,
Oh, yeah.
questions.
Screen's off for lag, but there's also that. Trey, thank you so much. This is really, really cool. And I love the way that you pulled in the primary sources. That was really cool to see, because I've read about a lot of these, but I haven't actually gotten to see the entries themselves. I was wondering if anyone has done a survey of non-famous letters and diaries of people mentioning these things. Because I'd be very, very interested to see that. And kind of from a social history perspective, see how people were responding to it, and whether there was any kind of SciComm going on, because I know that during some of this time, for instance, particularly in the 19th century, I know Jules Verne was effectively writing SciComm. And this seems like the sort of thing he would have been really interested in, but I haven't read any of the books where he talked about this. But kind of wondering, like, what was the education out to people, or was it that sort of 18th century Enlightenment, like ivory tower, like we hold the knowledge, and this separates us, that Thomas Jefferson so strong at.
I will tell you that what I do see, so that's a very interesting point, and I haven't seen a lot of what you're talking about as far as just general correspondence from people and how people wrote about it. I haven't seen any. It may be out there, but if it is, I haven't seen anything like that. But I agree, that would be very interesting to look at.
Yeah.
The most I've seen is you start to see in the 1800s, you start to see some kind of the beginnings of meteorology textbooks, or not even just textbooks, but books about meteorology written for more general audience. And you do start, and at that time, the aurora was considered a part of meteorology. And so you do, in those writings about kind of our early understandings of meteorological science, you do see the inclusion of the aurora and kind of what's the latest, our best understanding of the aurora. You see that in the Encyclopedia Britannica and things like that. And that's about the extent of what I've seen as far as writing about it for a more general audience. I know that's not exactly what you were asking about, but that's about the best of what I've seen, and kind of in that regard.
That's really cool. It was literally a question that was going to be, do I need to get back into my William and Mary databases and start taking a look around? Thank you so much, Trey. I'm going to pass on to Chris.
Cool, thanks. I think the bit out of that presentation that jumped out at me that I really enjoyed were the comparisons of observations across latitude. And for the time period, being able to take all those different observations from different places that would take so long to travel across, I really enjoyed that. Being able to say that at more northern latitudes, the aurora appears more vertical. And then as you get south, it appears tilted. That's a really cool observation for the time period.
Yeah, because it wasn't easy to get that information back then.
Yeah. Well, and to be able to compare it, you'd either have to be traveling a lot or you'd be comparing observation notes between different people.
Right.
And either of those are going to be challenging.
Yes, absolutely.
Also for Carol, in Canada, this is not going to, maybe it'll focus. In Canada, we've got some currency that has the Aurora on it, limited edition, but it's a $20 coin that's got the Aurora and Steve on it.
Very nice.
I still want one of those. Going back to the history, it reminds me that kind of prior to the 1900s, the 20th century, there was a lot of, and this is in Karen Cooper's citizen science book, her first one, but basically the way science was done was more like citizen science, although not everyone had access to doing that. But when they talk about like this was written in a pamphlet, they really meant, I think, that it was printed and passed out at like traveling lectures and things like that. So they were starting to gather information from multiple sources that way. I've seen some, actually, I've seen some observations from what was, this is pretty late compared to what you were talking about, but the first magazine, which was like the London Register or something. It was a monthly magazine, and people who read it were typically like educated gentlemen of the time, but Mr. So-and-so reported lights in the sky, and someone else, you know, the next month would say something else. And so it was just very slow, but it did seem like the Twitter of the day. So yeah. Anyone else have any more thoughts? Thank you. Thank you so much. Hopefully we can, we'd all be very interested in part 2 for sure. Yeah.